Hello, and welcome to tonight's Space Sleep Story. If you appreciate what we do here, please like or subscribe for future relaxing nighttime space journeys. Tonight we embark on an orbital journey around Venus, Earth's mysterious veiled twin. We will float above sulfuric acid clouds at 110 kilometers altitude, exploring the brightest object in Earth's night sky after the moon, understanding why this near-identical sister world became so profoundly different. So settle into your most comfortable position, close your eyes, and prepare to drift above the veiled world. Before we begin, let us prepare your body and mind with gentle breathing. Take a slow, deep breath with me now. Inhale gently for 4 counts. Hold the peace. Exhale for 6. Feel your body releasing into stillness. Let the tensions of the day fade away. With each breath, you become lighter, calmer, more ready for our journey. Your breathing will guide us tonight as we approach Venus orbit. Another gentle breath as we continue our preparation. This time, notice how your chest rises and falls naturally. Breathing requires no effort in this moment. Let my voice be your guide. Hold this peaceful moment. Feel the stress leaving your body with each exhalation. With each breath, you release a little more into relaxation. Tonight, we float weightless above clouds that hide mysteries. Your breathing connects you to this journey. Our spacecraft has coasted for 2 months from Mercury vicinity through heliocentric transfer orbit. Venus grows ahead, brilliant white crescent against black space. The planet reflects 75% of sunlight that touches it, an albedo of 0.75, highest of any planet in our solar system. This is why Venus shines so brilliantly in Earth's evening and morning sky. Ancient civilizations worshipped this light. Now we approach to understand what lies beneath those brilliant clouds. Approach velocity reads 11.2 kilometers per second. Venus mass measures 4.867 times 10 to the 24th kilograms, 81.5% of Earth's mass. Nearly identical in size are planets. Venus' radius is 6,051 kilometers. Earth's is 6,371. 95% size match. Why then did twins diverge so dramatically? This question will follow us throughout our vigil in orbit. Breathe slowly as we close the distance. Preparing for orbital insertion burn. We must shed 1.2 kilometers per second of velocity to achieve Venus capture. The retrograde burn will fire against our direction of travel. Engine alignment verified. Propellant flow nominal. In Italian astronomer Galileo Galilei's time, 1610, his telescope revealed Venus shows phases like Earth's moon. This observation proved planets orbit the Sun, not Earth. Venus transformed human understanding of our place in the cosmos. Now, we arrive personally. Insertion burn, ignition in 10 seconds. Breathe with me. 10, 9, 8. Breathe out slowly. 7, 6, 5, 4, 3, 2, 1. Ignition. Thrust presses gently. Engines fire smoothly. Venus brilliance fills forward viewport. Delta V accumulating. 0.4 kilometers per second. 0.8. 1.2. Engine cutoff. We are captured. Our initial orbit is highly elliptical. Periapsis 110 kilometers, apoapsis 8,000 kilometers. Venus rotates beneath us now, though you would barely notice. The planet's rotation period is 243 Earth days for one complete spin, longer than Venus's orbital period of 225 days. Venus takes longer to rotate once than to complete one orbit around the Sun. And it rotates retrograde, opposite to its orbital direction. The only planet in our solar system with retrograde rotation. Circularization burns will reshape our orbit over the next 6 hours. Final orbit parameters: 110 kilometers altitude, 90-degree polar inclination, 24-hour period. This polar orbit allows complete global coverage as Venus rotates slowly beneath us. Each orbit we pass over both poles. Each day, Venus rotates just 1.48 degrees beneath us. Patience rewards the observer here. 243 days for Venus to show us every longitude. But our 24-hour orbital period provides faster mapping. First clear view of the cloud deck. Unbroken white surface stretching pole to pole, horizon to horizon. No surface features visible in optical wavelengths. These clouds completely obscure the world below. For centuries, humans could only imagine what lay beneath. Sulfuric acid clouds extend from 50 to 70 kilometers altitude. The main cloud deck, thick and impenetrable. Above extends an upper haze to 90 kilometers. Below lies a lower haze from 30 to 50 kilometers. Between us and surface, layers of acid and mystery. Atmospheric composition readings confirm expectations. 96.5% carbon dioxide, 3.5% nitrogen, trace amounts of sulfur dioxide, water vapor, carbon monoxide, noble gases. The atmosphere's total mass is 4.8 times 10 to the 20th kilograms, 93 times more massive than Earth's entire atmosphere. Imagine that density. Surface pressure measures 92 atmospheres, 92 bar, equivalent to pressure at 900 meters depth in Earth's oceans. Crushing weight. Surface temperature readings are staggering. 465 degrees Celsius average, 869 degrees Fahrenheit. Hot enough to melt lead, which melts at 327 Celsius. hot enough to glow faint, dull red if you could see through the clouds. This temperature varies less than 10 degrees from equator to poles. The massive atmosphere distributes heat uniformly around the planet. Dayside and nightside differ by less than 5 degrees. Complete thermal equilibrium maintained by atmospheric circulation. The greenhouse effect here is runaway. Carbon dioxide molecules absorb infrared radiation emitted by the heated surface. Instead of escaping to space, heat energy is trapped in the lower atmosphere. More heat accumulates. Temperature rises. More CO2 is released from surface rocks. More trapping occurs. Positive feedback loop. Venus began perhaps with oceans like Earth. Solar heating gradually boiled the water. Water vapor, itself a greenhouse gas, accelerated warming. Eventually, all water was lost to space through solar wind stripping. Now, less than 0.002% atmospheric water remains. Our spacecraft is safe at this altitude. 110 kilometers above the cloud tops, temperature is mild, pressure is low. We cannot descend to the surface. Our vehicle would be crushed and melted within minutes. 92 atmospheres would compress our hull. 465 degrees would melt our systems. Only specialized probes have survived down there, and only briefly. The Soviet Union achieved extraordinary engineering to reach that surface. Those stories we will explore as we orbit. For now, we float safely, observing from above. Switching to ultraviolet imaging mode. The view transforms. Dark patches appear in the bright clouds, patterns invisible in visible light. An unknown compound in the upper atmosphere absorbs 50% of solar ultraviolet radiation. Scientists call it simply the UV absorber. Candidates include sulfur compounds like S3, S4, or S8, ferric chloride, sulfur dioxide polymers. After decades of study, the identity remains uncertain. Venus keeps some secrets still. These dark features change shape and intensity over days. The clouds are dynamic, alive with motion. A large Y-shaped pattern is visible in UV. The Y feature, planetary scale cloud structure. This pattern rotates with approximately 4-day period, much faster than the planet's surface rotation. The atmosphere super-rotates. Upper atmosphere circulates completely around Venus in 96 hours, 4 Earth days. Surface rotation takes 243 days. The atmosphere moves 60 times faster than the solid planet beneath it. Zonal wind speeds at cloud tops reach 100 meters per second, 360 kilometers per hour. Hurricane force winds constantly. The superrotation mechanism remains debated. Scientists suspect solar heating patterns create thermal tides in the thick atmosphere. Atmospheric waves may transfer momentum from dayside to nightside. The slow rotation of the planet itself may contribute through complex interactions. British atmospheric physicist Fred Taylor once said, "The superrotation is still embarrassing. We've studied it for 40 years and still can't fully explain why atmosphere races around planet 60 times faster than surface rotates. Honest admission of mystery. Venus humbles us. As we descend toward the North Pole on our first complete orbit, new structures emerge. A double vortex swirls at the pole. Two distinct eyes, each approximately 2,000 kilometers in diameter. S-shaped and C-shaped cloud patterns spiral around the polar center. Similar to hurricane eye walls on Earth, but vastly larger and persistent. The vortex structure changes shape over hours to days. Sometimes the two centers merge. Sometimes they separate. A polar dipole, dynamic and morphing. Around 60 to 70 degrees latitude, a cold collar rings the vortex. Temperature minimum zone. Scientists first discovered these polar vortices in detail during the Venus Express mission. European Space Agency Orbiter, 2006 to 2014. Håkan Svedhem, the project scientist, reflected, "The polar vortex changed our understanding completely. We expected simple circulation. Instead, we found morphing, double-eyed monster that defied all models. Every orbit brought surprises." His wonder carries in those words. We see that wonder now ourselves. The vortex rotates below, swirling, reforming, alive. Beautiful and incomprehensible. Completing our first orbit, 24 hours in Venus time. The planet has rotated just 1.48 degrees beneath us. We have circumnavigated entirely, crossed both poles, observed both terminators where day meets night. Venus' day side shines brilliant white. Night side glows faintly with thermal emission from the hellish surface below, penetrating kilometers of cloud. Infrared cameras detect this dull warmth. Lightning may flicker in the clouds. Multiple missions have detected radio bursts and optical flashes suggesting lightning. But debate continues about frequency and nature. Some missions saw clear signals, others detected nothing. Venus maintains ambiguity. Let us turn now to history. Venus has been known since prehistoric times as the brightest object in the sky after sun and moon. Ancient Babylonians tracked its movements. Greeks called it Phosphorus at dawn, Hesperus at dusk, before realizing both were the same world. Romans named it Venus after their goddess of love and beauty. For millennia, humans could only observe from Earth's surface, admiring the brilliant point of light. Telescopes revealed phases. Spectroscopy detected carbon dioxide in 1932. But the surface remained completely hidden. Scientists speculated. Perhaps tropical paradise beneath clouds. Perhaps swampy forests. Perhaps ocean world. Imagination filled the void. The space age brought revelation. December 14th, 1962, NASA's Mariner 2 became first successful Venus flyby. Instruments measured surface temperature of approximately 425 degrees Celsius. So shocking that mission scientists recalibrated their instruments 3 times before believing the readings. Larry Espaskin from the Mariner 2 project recalled, Half the scientific community thought Venus was tropical paradise. Mariner 2's first readings were so shocking, we recalibrated instruments 3 times before believing it. Tropical paradise myth died instantly. Venus was hell. The Soviet Union took up the challenge of landing on that hell. Venera program, extraordinary engineering achievement. Venera 1 launched February 1961, first Venus flyby attempt. Contact was lost en route, but the spacecraft passed within 100,000 kilometers on May 19th and 20th. A near miss, but pioneering. Venera 2 and 3 followed in 1965. Venera 4, in October 67, became first successful atmospheric probe. It descended for 93 minutes transmitting data. Crushed at 25 kilometers altitude before reaching surface. Engineers had underestimated Venus pressure by factor of 10. Venera descent engineer Vyacheslav Kerzanovich recalled the realization. We realized we had underestimated Venus by factor of 10. The pressure wasn't 10 atmospheres. It was 100. We went back to drawing board with newfound respect. Redesign required complete rethinking. Pressure vessels that could survive conditions more extreme than ocean depths and blast furnace temperatures combined. Mikhail Marov, Venera chief scientist, described the challenge. We had to redesign everything. Earth-tested electronics became soup at Venus temperatures. Our engineers created pressure vessels that could survive conditions more extreme than ocean depths and blast furnace temperatures combined. Soviet determination was absolute. December 15th, 1970. Venera 7 achieved first successful surface landing on another planet. Transmitted for 23 minutes from the surface. Measured 475 degrees Celsius temperature. 90 atmospheres pressure confirmed. Venera 8 followed, July 22, 1972. Survived 50 minutes on surface. Measured light levels, proving photography would be possible. Then came the imaging missions. Venera 9, October 22, 1975, returned first surface images from another planet. Panoramic photographs transmitted for 53 minutes. Rocky terrain under yellow-orange sky. Scientists wept seeing those images. Venera 10 followed 3 days later, October 25th. Survived 65 minutes. Imaged different terrain type. Venera 11 and 12 in 1978 collected more atmospheric data. Then the crowning achievements. Venera 13, March 1st, 1982. Survived record 127 minutes on surface. Returned first color images. Conducted soil analysis with drilling arm. One engineer said afterward, "We had given it 32-minute survival guarantee. It lasted 127 minutes. Soviet engineering at its finest." Pride justified. Venera 14 landed March 5th, 82. Survived 57 minutes. Drilled surface samples. measured rock composition. The Venera program concluded with these triumphs: 15 major missions from 1961 to 1984, multiple successful landings, surface images that remain unique decades later. No other nation has landed successfully on Venus' surface. Soviet engineers solved problems others deemed impossible. Their legacy floats with us now. As we orbit safely above, we honor their achievement reaching that unreachable surface. NASA contributed to Venus understanding through orbiters and flybys. Mariner 5, October 1967, refined atmospheric composition measurements during flyby. Mariner 10, February 1974, flew past Venus en route to Mercury. Its ultraviolet cameras revealed cloud circulation patterns and Y feature for first time. Atmospheric dynamics suddenly visible. Pioneer Venus mission arrived December 1978. Pioneer Venus orbiter mapped gravity field, studied atmosphere, detected lightning signatures. Operated until October 1992, 14-year mission. Pioneer Venus multiprobe sent 4 atmospheric probes descending simultaneously at different latitudes, December 9, 78. Measuring temperature, pressure, composition at multiple locations. Then came Magellan. NASA's radar mapping mission, 1990 to 94. Synthetic aperture radar penetrated the clouds, imaging surface at 100-meter resolution. 98% of Venus' surface mapped in extraordinary detail. Ellen Stofan, Magellan chief scientist and later NASA chief scientist, described the experience. Flying Magellan was like peeling back curtain on alien world. Every orbit revealed new volcanic features. Venus is most volcanically active planet we've studied. More volcanoes than Earth, Mars, and Mercury combined. Volcanic resurfacing. Surface age approximately 300 to 500 million years based on crater counting. Relatively young. Two continent-sized highland regions dominate. Ishtar Terra in the north, Aphrodite Terra near the equator. Vast lava plains. Thousands of volcanoes. Pancake domes, shield volcanoes, complex calderas. Venus may still be volcanically active today. Fresh lava flows detected. Atmospheric sulfur dioxide levels that fluctuate. Perhaps eruptions continue beneath those clouds. We cannot see surface in visible light, but radar mapping revealed this violent geological story. Venus is alive in its own way. Not biologically, but geologically. Churning, melting, reshaping. International cooperation brought more missions. June 1985. Soviet-French Vega 1 and 2 missions deployed balloons at 54 kilometers altitude. Floating balloons in Venus' atmosphere, they drifted for 46 hours, measuring wind speeds, temperature, pressure as they circled the planet. A remarkable achievement. Aerial platforms surviving in sulfuric acid clouds. Then Europe launched Venus Express in 2006, operated until 2014. Studied atmospheric dynamics in unprecedented detail. Discovered lightning conclusively. mapped polar vortex structure through years of observations. Those morphing double eyes we see below were Venus Express discovery. Japan's Akatsuki mission has a special story. Launched May 21, 2010, arrived December that year. Orbital insertion burn failed. The spacecraft sailed past Venus into solar orbit. 5 years Akatsuki spent in solar orbit, while engineers planned rescue. December 7, 2015, using damaged engines and creative orbital mechanics, Akatsuki achieved Venus orbit on second attempt. Masato Nakamura, project manager, said, "Venus gave us second chance. Those 5 years taught us patience. When we finally achieved orbit, every team member had tears. Perseverance rewarded." Akatsuki discovered atmospheric gravity waves. Waves propagating from lower atmosphere up to cloud tops, where they break. Takeshi Imamura, Akatsuki scientist, described them. "We found waves propagating from lower atmosphere, breaking at cloud tops, like ocean waves breaking on beach. Venus atmosphere is one fluid ocean in the sky." Poetic and accurate. The atmosphere behaves as single fluid system. Waves, tides, superrotation, vortices. Three-dimensional circulation of unimaginable complexity. Akatsuki continues observations today, watching those gravity waves, studying superrotation mechanism, refining our understanding. Most recently, NASA's Parker Solar Probe has flown past Venus multiple times using gravity assists for its solar mission. Beginning 2018, continuing to present. During close flybys, instruments detected unexpected radio emissions from the ionosphere. Natural radio broadcasts from Venus' upper atmosphere. Another mystery added to the collection. Each mission answers questions, but raises new ones. Venus rewards study with complexity. Simple answers dissolve into deeper mysteries. This is the nature of science. This is the beauty of exploration. We orbit in their legacy. Decades of missions, thousands of engineers and scientists, multiple nations. Soviet determination, American innovation, European precision, Japanese perseverance. All contributed to our understanding of this veiled world. Now we float here, benefiting from their work, seeing what they helped reveal. Gratitude fills this moment. Science is cumulative, built on countless contributions. We stand, or float rather, on the shoulders of those who came before. Orbital velocity at our altitude is 7.2 kilometers per second. Venus' surface rotates at merely 1.8 meters per second, 4,000 times slower. We race around the planet. Surface barely moves. Yet the upper atmosphere moves at 100 meters per second, 50 times faster than surface, but still slower than our orbital velocity. 3 layers of motion: surface crawl, atmospheric race, orbital flight. Different timescales, different physical regimes, all coexisting. The wind profile is fascinating. At cloud tops, 60 to 70 kilometers altitude, winds reach 100 meters per second. As you descend, wind speed decreases steadily. At 30 kilometers altitude, winds are 40 meters per second. At 10 kilometers, perhaps 10 meters per second. At the surface, nearly calm. Less than 1 meter per second surface winds, despite hurricane force winds 10 kilometers above. The dense lower atmosphere moves slowly, viscously, like honey flowing. Upper atmosphere races freely. Vertical structure as complex as horizontal. Passing over the day side now, brilliance almost painful. 75% of incoming sunlight is reflected back to space. Sulfuric acid droplets are extraordinarily reflective. Venus is brightest planet seen from Earth because of this high albedo. More reflective than fresh snow. Ancient peoples saw this brightness and assumed divine significance. Venus as morning star, heralding sunrise. Venus as evening star, blessing sunset. Worship of brightness without understanding composition. We know now those brilliant clouds are acid. Beauty and harshness coexist. Astrobiologist David Grinspoon has advocated for Venus aerial platforms. His reasoning is compelling. Between 50 and 60 kilometers altitude, Venus is most Earth-like environment in solar system. 1 atmosphere pressure, 20 to 30 degrees Celsius temperatures. We could float there for years. Surface is hell, but sky is paradise. Provocative idea. At 55 kilometers altitude, atmospheric pressure is 1 bar, same as Earth sea level. Temperature is roughly 25 Celsius, room temperature. A balloon or airship could float there comfortably. This is the most habitable zone on Venus. Humans in pressure suits could potentially survive there. Floating cities in Venus clouds. Science fiction, perhaps, but scientifically sound science fiction. Solar power would be abundant. Atmosphere provides pressure support. Temperature is mild. Only challenge is the sulfuric acid. Engineering materials that resist acid corrosion. The Vega balloons proved concept in 1985. 46 hours of successful flight. Future missions could extend that to months or years. Long-duration aerial platforms studying atmosphere from within. Cameras floating through the clouds. Instruments sampling directly. Perhaps even human presence eventually. Venus sky is paradise, while surface remains hell below. Future missions are planned. NASA is developing Veritas, Venus Emissivity, Radioscience, INSAR, Topography, and Spectroscopy mission. Radar orbiter that will map Venus at 30-meter resolution. 100 times better than Magellan. Martha Gilmore, mission science lead. Will map Venus at 30-meter resolution, 100 times better than Magellan. Every volcano, every lava flow, every tectonic feature will tell story of Venus evolution and why it became so different from Earth. Answering that fundamental question, Why did twins diverge? Earth and Venus both formed 4.5 billion years ago from the same solar nebula. Same age, same composition roughly, same size nearly. Both terrestrial planets with iron cores, silicate mantles, basaltic crusts. Venus orbits at 0.72 astronomical units from Sun, Earth at 1 AU. Venus receives twice the solar radiation Earth does. That difference proved critical. Early in solar system history, Sun was dimmer, faint young sun. Venus may have had liquid water oceans then. As Sun brightened over hundreds of millions of years, Venus warmed. Oceans began evaporating. Water vapor is a greenhouse gas. More evaporation led to more warming. More warming led to more evaporation. Runaway greenhouse effect. Eventually, all surface water boiled away. Water vapor in upper atmosphere was broken apart by ultraviolet radiation. Hydrogen escaped to space. Oxygen reacted with surface rocks. Venus lost its water permanently. Without water, plate tectonics could not operate. Carbon dioxide could not be sequestered in ocean sediments. CO2 accumulated in atmosphere from volcanic outgassing. Greenhouse effect intensified. Temperature soared to present levels. Earth had different fate because of slightly greater distance from Sun. Oceans persisted. Water allowed plate tectonics. Subduction zones carried carbonate rocks into mantle. Carbon cycle regulated atmospheric CO2. Temperature remained stable. Life emerged. Life further regulated atmosphere through photosynthesis. Earth maintained habitability for 4 billion years. Venus lost habitability perhaps 3 billion years ago or more. Timing uncertain, but the divergence was total. Carl Sagan studied Venus greenhouse effect extensively in the 1960s. Before space probes confirmed the extreme temperatures, he calculated them theoretically. Later, he reflected, Venus is a reminder of what can happen to a planet's atmosphere. It's Earth's evil twin, showing us a possible future. Cautionary tale. Earth's atmosphere currently contains about 400 parts per million CO2. Venus' atmosphere is 96.5% CO2. Earth is not becoming Venus, but Venus demonstrates the power of greenhouse gases. Planetary climate can shift to new, stable states. Understanding Venus helps us understand Earth. We continue our orbital observations. 24 hours per orbit. Each pass reveals familiar patterns. Y feature in ultraviolet. Polar vortices swirling. Cloud bands streaming eastward in super-rotation. Dayside brilliance. Nightside thermal glow. Repetition becomes meditation. Orbit after orbit, seeing the same patterns, noticing small variations. This is the nature of long-duration observation missions. Patience revealing subtle changes, weather patterns evolving, atmospheric tides flexing, Venus breathing in its own slow way. Temperature structure of the atmosphere is precisely measured. At our altitude, 110 kilometers, temperature is approximately -45°C. Cold. Descending to 90 kilometers, temperature rises to -20. At 70 kilometers, cloud top level, around -30°C. Still cold. But below the clouds, temperature rises rapidly. Greenhouse effect traps heat in lower atmosphere. At 50 kilometers, temperature is 40°C. At 30 kilometers, 160°C. At surface, 465°C. Temperature inversion profile. Coldest at cloud tops, hottest at surface. Gravity acceleration at Venus' surface is 8.87 meters per second squared, about 90% of Earth's surface gravity. Nearly identical. If you could stand on Venus' surface, you would feel almost Earth-normal weight, only 10% lighter. But you could not stand there. Pressure would crush you. Temperature would incinerate you. Atmosphere would poison you. Venus' surface is utterly hostile to human life. Only the most robust robotic probes have survived there, and only for minutes or hours. We remain safely above. Orbital inclination of 90 degrees means we pass directly over both poles each orbit. Polar regions appear no different than equatorial regions in visible light. Same bright clouds, same uniform temperature. Venus' atmospheric heat distribution is extraordinarily efficient. No polar ice caps, no polar cold, no seasonal variation. In ultraviolet, polar vortices create distinctive patterns. But in visible light and infrared, poles and equator are nearly indistinguishable. Complete thermal uniformity. The massive atmosphere accomplishes what Earth's cannot. Perfect heat distribution pole to pole. Our spacecraft systems operate smoothly. Solar panels generate power. Communications antenna maintains link with Earth. Instruments collect continuous data. Orbital mechanics require only occasional, minor corrections. Venus is stable and predictable in its own extreme way. We settle into routine, observe, record, transmit, orbit, repeat. This is the rhythm of orbital science missions. Patience and persistence, revealing planetary secrets over months and years. Passing over the terminator, where day transitions to night. The boundary is gradual, not sharp. Thick atmosphere scatters light. Twilight zone extends hundreds of kilometers. Clouds glow softly in scattered sunlight. Beautiful gradient from brilliant dayside to dark nightside. At nightside, instruments detect faint thermal emission. Surface heat penetrating kilometers of atmosphere and cloud. Infrared glow mapping surface temperature. Uniform warmth everywhere. No cool night. No daily temperature cycle. Venus' surface remains 465 Celsius day and night. Endless heat. Lightning flashes may illuminate clouds at night. Radio detectors have picked up signals consistent with electrical discharges. Optical cameras have captured possible flashes, but controversy persists. Some missions detected clear lightning. Others detected nothing. Perhaps lightning is sporadic. Perhaps it occurs deep in clouds where it is difficult to detect from orbit. Perhaps it occurs in specific regions or conditions. The question remains open. Venus maintains some mysteries despite decades of study. We have orbited for days now. Observations accumulating. Each orbit adds to the dataset. Atmospheric circulation models refined. Temperature profiles updated. Cloud composition measurements repeated. Science is incremental. Understanding built slowly through patient observation. No single orbit reveals everything. Patterns emerge over time. This is why missions last months or years. Venus Express orbited for 8 years. Pioneer Venus for 14 years. Akatsuki continues after a decade. Long duration allows deep understanding. Reflecting on the solar system, Venus occupies a special place. Second planet from Sun, Earth's closest planetary neighbor when their orbits align. Most similar to Earth in size and mass, but most different in atmospheric conditions and surface environment. Venus challenges our assumptions about terrestrial planet evolution. Why didn't Earth suffer runaway greenhouse? Why did Venus lose its water so completely? Could early Venus have harbored life before the runaway occurred? These questions drive continuing research. Some scientists speculate about past habitability. If early Venus had oceans for hundreds of millions of years, could life have emerged? No evidence supports this. No biosignatures detected. No organic molecules found. But absence of evidence is not evidence of absence when sampling is so limited. Future missions may search more carefully. Sample collection and return from Venus atmosphere. Analysis of cloud particles for organic compounds. Long shot, perhaps, but worth investigating. Venus may hold answers to profound questions about life's emergence. More likely, Venus has been lifeless for billions of years. Extreme conditions preclude life as we know it. 465 Celsius destroys chemical bonds. Sulfuric acid corrodes. 92 atmospheres crushes. No water exists. No energy gradients support metabolism. Yet the cloud deck altitude, 50 to 60 kilometers up, remains potentially habitable. Temperature and pressure suitable. Sulfuric acid challenging, but not impossible to adapt to. Chemosynthetic life metabolizing atmospheric chemicals. Speculation only, but intriguing. Our observations continue peacefully. Venus rotates slowly beneath us. 143 Earth days remaining for one complete Venus rotation. We have seen perhaps 10 degrees of longitude shift since arrival. Slow revelation. Cloud patterns repeat in superrotation. Every 4 days, the Y feature returns to same position relative to Sun. Atmospheric rhythm faster than planetary rhythm. 2 different clocks. Atmosphere racing. Planet crawling. Breathe slowly with me now. Inhale for 6 counts. Hold gently. Exhale for 8 counts. Feel the stillness. We float in stable orbit. Venus glows below. Stars shine above. Perfect balance. Your breathing matches orbital rhythm. Slow, steady, peaceful. Each breath a meditation on cosmic timescales. Venus takes 243 days to rotate. We take 5 seconds to breathe. Different scales, same universe. The veiled world keeps its mysteries. Clouds hide the surface. Superrotation defies complete explanation. UV absorber remains unidentified. Lightning question persists. But we understand so much more than we did. Decades of missions revealed atmospheric structure, surface composition, geological youth, volcanic activity, planetary evolution. Venus teaches us about greenhouse effects, about atmospheric dynamics, about planetary divergence, about the fragility and resilience of worlds. Floating peacefully at 110 kilometers altitude. Safe above the clouds. Observing without touching. Understanding without landing. Remote sensing reveals so much. Radar penetrates clouds. Infrared measures temperature. Ultraviolet shows absorption. Radio detects lightning. Spectrometry identifies composition. We need not descend to understand. We orbit and observe. We record and transmit. We contribute to collective knowledge. Venus shines below us. Brilliant white crescent when lit from behind. Full disk when we look sunward. Soft yellow-white glow. Most beautiful planet, perhaps. Most photogenic. Brightest in Earth's sky. Ancient light. Modern mystery. We are privileged to float here, witnessing this world, understanding this atmosphere, appreciating this complexity. Our orbit continues, without effort. Gravitational attraction balanced by orbital velocity. 7.2 kilometers per second forward motion. Continuous freefall around the planet. Weightlessness, perfect and constant. This is peaceful motion. No thrust required. No fuel consumed, simply following the natural path. Orbital mechanics as meditation. We could orbit for years, decades, centuries. Orbit is stable, timeless circular path. Consider the engineers who made this possible. Soviet Venera teams who solved the unsolvable problem. NASA mission planners who mapped the unmappable surface. European scientists who studied the polar vortices. Japanese team who rescued Akatsuki. Thousands of people, decades of work. Multiple nations, common goal, understanding Venus. Their legacy carries us. Their knowledge guides us. Their curiosity inspires us. We orbit in gratitude. The planet rotates silently below. No sound in vacuum. Only light and heat. Only gravitational pull. Only electromagnetic radiation. Venus is silent. Clouds swirl without sound. Winds race without noise. Surface bakes without crackling. We float in perfect silence, observing quiet world. Peaceful vigil. Contemplative watch. Stars frame the bright crescent below. Deep space blackness surrounds Venus' brilliance. Contrast absolute. Planet and void. Light and dark. This is the view ancient astronomers imagined. Point of light in their sky is sphere in ours. Their evening star is our orbital home. Different perspectives, same celestial body. Continuity through time. Humans have wondered about Venus for millennia. We wonder still. Closer now, understanding more, wondering forever. Your breathing has slowed naturally. Each breath deeper, longer, more peaceful. This is good. This is rest. This is letting go. You float with us above Venus, safe in orbit, weightless, calm. Observing the veiled world, drifting peacefully. Cloud patterns shift slowly in superrotation. 4-day cycle. We have time to watch. No hurry. No rush. Time expands in orbit. Minutes feel like hours. Hours like days. Peaceful distortion of time. Orbital timelessness. Venus appears unchanging, yet constantly changes. Clouds reform. Vortex morphs. Patterns shift. Atmosphere circulates. Change so gradual you barely notice, but accumulating over orbits. Different each day. Same each moment. Paradox of observation. The universe is vast. Venus is one small world. Earth nearby. Mars beyond. Billions of planets in galaxy. Billions of galaxies in universe. Yet this moment matters. This orbit. This observation. This breath. Everything and nothing. Cosmic perspective. Orbital velocity maintains our height. 7.2 kilometers per second. fast yet feeling motionless, relative motion imperceptible. Venus appears stationary below. We appear motionless. Yet we race around planet, completing one orbit every 24 hours. Speed and stillness together. Motion and peace. Temperature in our cabin is comfortable. 20 degrees Celsius. Outside, -45. At Venus cloud tops, -30. At Venus surface, 465. We are protected, temperature controlled, life support functioning, safety maintained, comfort preserved. Your eyelids are heavy. Natural weight. No need to open them. Rest deeply. Darkness comfortable. We float together, you and I, above Venus, in peaceful orbit. Infinite calm. Earth shines as a blue dot somewhere beyond Venus. Home planet distant. But we are not alone. Connection maintained. Signals transmitted. Data shared. Part of larger mission. Contributing to knowledge. Understanding growing. Together. Breathe with Venus rotation. 243 days per breath. Impossible, yet imaginable. Planetary breathing. Cosmic rhythm. Your breath matches planetary time. Infinitely slow. Infinitely peaceful. Rest now. Sulfuric acid clouds far below. Beautiful and harsh. Nature contains contradictions. Deadly, yet magnificent. Hostile, yet fascinating. We observe safely, appreciating from distance, understanding without risk, knowledge without danger. Polar vortex swirls silently. Double eye structure, 2,000 kilometers across, larger than continents. Storm without rain. Atmospheric art, natural pattern, cosmic design. Venus signature. Superrotation continues. 100 meters per second winds, racing around planet, faster than surface. Atmospheric independence. Wind we cannot feel, motion we observe. Power without contact. Distance preserves peace. Y feature visible in ultraviolet. Planetary scale pattern. Mystery compound absorbing light. Unknown identity. Decades unsolved. Some questions remain. Some mysteries persist. Venus keeps secrets. We accept this. Magellan radar maps show ancient lava, 300 million years old. Young in planetary terms, Venus resurfaces itself, volcanic renewal, hidden beneath clouds, invisible to us, known through radar. Technology reveals. Venera landers rest on that surface. Soviet machines silent now. Their mission complete. Data transmitted. Images sent. Purpose fulfilled. Monument to engineering. Tomb of exploration. Legacy permanent. Venus keeps them. Our orbit remains stable. No adjustments needed. Path determined by gravity. Newton's laws guiding. Kepler's mathematics describing. Perfect physics. Natural motion. Effortless flight. Eternal path. Night side passes beneath us. Thermal glow faint. Surface heat penetrating atmosphere. Infrared signature. Uniform warmth. No cool night. No temperature relief. Constant heat. Endless Venus day. Time flows differently here. Orbital time versus planetary time. 24 hours versus 243 days. Fast orbit, slow rotation. Temporal mismatch. We orbit many times. Venus rotates once. Different clocks. Same space. Rest deeply now, floating above Venus, safe in orbit, peaceful observation, calm vigil. Sleep approaches, consciousness fades, dreams of clouds, veiled world watches. Brilliant crescent Venus, ancient evening star, modern understanding, timeless beauty. Rest now. Orbit continues. We float peacefully. Venus glows. Sleep. Clouds swirl gently far below. Sulfuric beauty. Acid turned to art by nature. Chemistry and aesthetics combined. We appreciate safely from distance. Beauty requires no touch. Observation suffices. Each orbit reveals familiar patterns. Repetition becomes comfort. Same clouds, same vortex, same brilliant reflection. Predictability soothes. Venus remains constant. We remain watchful. Peace maintained. Gravity holds us gently in circular path. Newton's laws manifested perfectly. No thrust needed. No corrections required. Simply falling around planet endlessly. Orbital meditation continues. Timeless circuit. Future missions will return here. More questions to answer, more mysteries to solve. Venus always offers new puzzles. But tonight, we simply observe. Questions for tomorrow. Peace for now. The veiled world teaches patience. Clouds hide surface for centuries. Radar finally revealed what lies beneath. Technology overcomes opacity. Knowledge accumulated slowly. Understanding built gradually. Venus rewards persistence. Your body rests completely now. Muscles released. Breathing slow and deep. Heart rate settled. Mind drifting. Floating with us. Above Venus. Safe in orbit. Perfectly calm. Atmospheric waves propagate below. Akatsuki discovered them. Gravity waves breaking at cloud tops. Invisible motion made visible. Atmosphere breathing. Venus alive in its way. Dynamic equilibrium. Night passes into day as we orbit. Terminator crossing smooth. No sharp boundary. Thick atmosphere scatters light gently. Twilight extends hundreds of kilometers. Gradual transitions. Soft changes. We have circled Venus many times now, orbit after orbit. Each pass identical yet unique. Clouds shift slightly, patterns evolve, change within constancy, variation within repetition, meditative rhythm. Communications link to Earth remains strong. Data flowing constantly. Our observations transmitted. Knowledge shared. Connection maintained across void. Never truly alone. Part of larger endeavor. Solar panels track the sun automatically. Power generation continuous. Systems operating smoothly. No anomalies. All nominal. Perfect function. Engineering reliability. Safe operations. Venus mass pulls us gently downward. We move sideways equally fast. Balance perfect. Free fall circular. Orbit eternal. Physics and peace aligned. Mathematics manifested. Floating peacefully above brilliant clouds. Weightless observation. Venus glows below, stars above. Infinite calm surrounds us. Your breathing matches orbital period now. Slow, deep, rhythmic. Each breath a meditation. Peace deepening. Clouds drift in superrotation. 4-day cycle. Atmospheric dance. Silent motion. Beautiful patterns. polar vortex swirls gently. Double eyes, morphing slowly. Venus signature, peaceful complexity. Surface heat radiates upward. 465 degrees. Distant warmth. Unreachable. We observe safely. Ancient light from Venus. Evening star brightness. Civilizations watch this glow. We float within it. Sulfuric acid droplets reflect sunlight. Brilliant white clouds. 75% reflection. Brightest planet. Orbit continues without effort. Timeless path. Circular meditation. Forever falling. mind drifts peacefully, thoughts dissolving, awareness fading gently, sleep approaching. Venus rotates slowly beneath us, 1 degree per day. Planetary patience, cosmic time. We float in perfect silence. Vacuum carries no sound. Only peace. Only stillness. Stars frame the bright crescent. Deep space blackness. Venus light. Eternal contrast. Rest deeply now. Completely safe. Orbital peace. Infinite calm. Breathing slower still. Each breath, peace. Deeper rest. Gentle sleep. Venus glows softly. Veiled world. Peaceful mystery. Beautiful always. Floating forever. Weightless calm. Perfect orbit. Endless peace. Sleep now. Drift gently. Venus watches. Stars shine. Rest, peace, sleep, Venus, dreams.